Now let's quickly go over to different operations which can be done. So we'll cover the basic ones. Of course, there are a lot more than this. This we have seen like how to create two different matrices. Okay, so these are two different tensors. If we have to add these, you can just call torch.add and pass these as variables. And again, print, we'll just print the values. Indexing is something like very powerful coming from Python. The same indexing also applies for PyTorch. And and as I said, like Python was a prerequisite, so you should know all of this already. It's just, I think the new piece of information will be, this can also be done in PyTorch. Okay, so what this operation is trying to do here is, if X is a 4x4 matrix, you are actually indexing the first dimension, or you can say like the first row of the second dimension here, and you are taking all the values in the first dimension. All right, so this is going to give you like a one-dimensional vector with 4 values. Resizing is also very useful. I think when you design your network, you will see like it's very useful at a lot of places. Let's say this is your vector, and this is a little complicated, but not that hard. Okay, so if this is a 4x4 matrix, then you know that this will have 16 different values. And let's say you want to convert this matrix into a one-dimensional vector. So you can do that using this view function here. So view is something like, what's the target shape you want? In this case, it's telling you the target shape is 16. And y will be just like a one-dimensional vector with 16 values. And those 16 values will be coming from this 4x4 matrix. And you know this has 16 values, so you can do this. Which means that not all operations will be valid for view. You will have to make sure that you know how many elements you have in your input data. Okay. So this is like another very interesting use of view. Again, it will be very useful. What it's trying to do is, so this is x.view, which means that we are trying to reshape the x tensor over here, and the shape is, when you have -1, it means you don't care. All right, so it's like something you can the library will automatically compute for you. So whatever this number is, you don't care about this. So that's -1, and 8 is something you're saying the second dimension should be 8. Now you know that this is 4x4, again two-dimensional matrix. This is again a two-dimensional matrix. Second dimension is 8. So automatically the first dimension will be 2, right? Because this has 16 values. So it has to have 2 values that will make it 8 × 2, 16. Because you can't like change the number of values you have in your matrix, right? So that 2 will be automatically computed by the library, and you just put don't care here. And again, you can print like the sizes. So x.size, you know, it's 4x4. Y, since you reshape it to like a one-dimensional vector, it will have 16 different values. And z, you put like a two-dimensional matrix where the first dimension is don't care. That's going to give you 2 × 8. Okay, slightly complicated, but I don't think it's very complicated to be able to understand.